Hello students, in this session we are going to apply Paired W test that is applicable for the comparison of two population means when we are given dependent samples that we can treat as paired samples. And in addition to that, the underlying assumption related to the behavior of the data is data we assume to be approximately symmetrical, as the normality test results are not indicating that the behavior of the data or the data follow normal distribution. So, first of all, we have to write down the null hypothesis and the alternate hypothesis for the same question in the same way. And the question that we have dealt with in case of paired T, we are using the same question in which we have or we are given before program cholesterol level, after program cholesterol level of 10 patients, and we have computed in case of the application of paired t-test, we have computed paired differences. We are now using the same example or question to answer hypothesis testing for the paired W test. So, paired W test. That's mean cholesterol level before equals mean cholesterol level after. H1 is mu before is not equal to mu after. So this is the two-tailed test. Level of significance. Because of the two-tailed test, we have to divide alpha by 2. And test statistic is paired W, the result of which we get in a standardized form again. And decision rule or criterion, we write down same as usual, that H0 would be rejected if p-value associated with W statistic or standardized Z statistic that the software will compute for W is very small, or as a yardstick it will be less than 0.05. Now we go for writing down decision and conclusion, but before that we are going to perform this test in SPSS. And this is analyze non-parametric test, and we go for two related samples. We take cholesterol before as variable 1 and cholesterol after as variable 2, and the check mark across Wilcoxon test is already there. We paste this and we run this selection, and we can see that the result is the case of rejection, but at the 3.5% significance level or less than that. So it is not, it is the case, so this is the case of rejection at 5%, but not at the case at a percentage of 1. So it is not statistically significant at 1% significance level. But if we consider 5% as the rejection criterion for one tail test, only then this can be considered as a rejection in the right tail zone. Over here, why it is indicating right tail even though the sign with these statistics is mentioned as negative? If you look at the order in which the software has considered the data, it has taken cholesterol level after first and cholesterol level before later on or second in order. So it has changed the order of the data on its own. So we were originally performing the test as a right tail, but since the software has changed the order and it indicates that this is a case of rejection in the left tail. And again, cholesterol level after program is significantly less than that of the cholesterol level before the program. And therefore, we can add as the two-tailed test, this is the case of non-rejection, but as the one-tailed test at 3.5%, this is the case of rejection. Or at 5% significance level, this is the case of rejection. Originally, this question was given as before cholesterol, before program cholesterol level, or average cholesterol level before the program is significantly greater than that of average cholesterol level after the program. That can be alternatively written down as cholesterol level after is less than cholesterol level before the program. So according to this specification, we need not to divide alpha by 2, rather we take it as a left tail test, and at 5% significance level, this is the case of rejection. So we can say that H naught would be rejected as the significance level or the p-value for a left tail test is less than 0.05. Okay, and Cn we can write down as, since p-value corresponding to W statistic is less than 0.05, therefore H naught is rejected, and it can be concluded that the program is effective in reducing cholesterol level. This is how we do it, or we can perform a paired W test under the condition when we are given the sample data as the dependent samples and with an assumption that the data do not follow approximately normally distributed, or the pair differences do not follow approximately normally distributed behavior. So that's all from this topic.